When considering a 200 amp feed using 4/0 aluminum quad Plex cable, several factors come into play. Firstly, let's examine the National Electrical Code, or NEC, requirements. According to NEC section 250.122, a number 4 aluminum conductor is permitted for equipment grounding for a 200 amp service. Secondly, consider the type of cable itself. Quad-plex cables are generally designed for outdoor applications and aren't typically used indoors. The use RHH, RHW insulation rating indicates suitability for outdoor environments. One must address several key concerns. Firstly, conduit requirements. Quad-plex cables cannot be installed inside conduit because of their shape. If any part of the cable run is exposed within the house, it needs protection using conduit or other approved methods. Secondly, there's the issue of corrosion. Aluminum is more prone to corrosion than copper, which becomes particularly important if the cable might be exposed to moisture or chemicals. Thirdly, ampacity derating. Aluminum conductors have a lower ampacity than copper conductors. This means the 4/0 aluminum conductors may require derating, particularly over a 28-foot run. Considering these factors, several recommendations can be made. Firstly, if the cable will be exposed, it's advisable to use a copper feeder with a larger grounding conductor such as number 4 copper or larger. Secondly, if the cable will be installed in conduit, it's still recommended to opt for a copper feeder with a larger grounding conductor. Thirdly, if the cable will be exposed and you're still considering using the 4/0 aluminum quad Plex, understand the potential risks. You'll need to take precautions to protect the cable from corrosion and mechanical damage. Remember to always adhere to all NEC requirements and local electrical codes. It's highly recommended to consult with a licensed electrician to ensure proper installation and safety. Exercise caution when handling and installing aluminum cables, because improper handling can lead to damage or unsafe conditions. To elaborate on NEC 250.122, this section details the minimum size of equipment grounding conductors for grounding raceway and equipment. The table within this section correlates the size of the overcurrent protective device, such as a circuit breaker or fuse, with the minimum size of the grounding conductor. For a 200 amp overcurrent device, number 4 aluminum is indeed listed as an acceptable size. However, it is critical to understand that this is a minimum requirement. Many electricians choose to upsize the grounding conductor for enhanced safety and performance. Going back to the quad Plex cable, the fact that it contains two 4/0 conductors, one 2/0 conductor, and one number 4 conductor is important. The two 4/0 conductors are intended for the ungrounded or hot wires carrying the primary current. The 2/0 conductor is typically used as the neutral conductor, and the number 4 conductor is the equipment grounding conductor. The use RHH, RHW ratings indicate the insulation properties of the conductors. Use stands for underground service entrance cable, indicating it is suitable for direct burial applications. RHH stands for rubber heat resistant, indicating the insulation is heat resistant. RHW stands for rubber heat and water resistant, further specifying the insulation's resistance to both heat and water. When considering indoor use, a primary concern with quad Plex cable is its lack of a protective outer jacket. Indoor wiring methods, such as NMB cable, typically have a non-metallic jacket to protect the conductors from physical damage. Because quad Plex lacks this jacket, it's more vulnerable to damage if installed in an exposed location. This is why it's often recommended to install it inside conduit if used indoors. The conduit provides the necessary physical protection. Addressing corrosion concerns with aluminum, it's true that aluminum oxidizes when exposed to air. This oxidation forms a layer of aluminum oxide on the surface of the conductor. While this oxide layer is actually a good insulator and protects the underlying aluminum from further corrosion, it can also create problems at connections. Aluminum oxide is non-conductive, which can lead to loose connections and overheating. To prevent this, it's essential to use connectors and terminals that are specifically designed for use with aluminum conductors. These connectors are typically coated with an antioxidant compound that helps to penetrate the oxide layer and establish a good electrical connection. Furthermore, regularly checking and tightening connections is crucial to maintaining a safe and reliable electrical system. Ampacity derating is another important consideration when using aluminum conductors. Ampacity refers to the current carrying capacity of a conductor. The NEC provides tables that specify the ampacity of different conductors based on their size, insulation type, and ambient temperature. Aluminum conductors generally have a lower ampacity than copper conductors of the same size. This means that a 4/0 aluminum conductor will have a lower ampacity than a 4/0 copper conductor. When running conductors over a long distance, voltage drop can become a concern. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. The longer the conductor, the greater the voltage drop. Excessive voltage drop can cause appliances and equipment to operate efficiently or even fail. To mitigate voltage drop, it's often necessary to upsize the conductors. In the case of a 28-foot run, voltage drop may not be a significant concern, but it's still something to consider. The NEC provides formulas and guidelines for calculating voltage drop. When making the transition from an outdoor main panel to an indoor subpanel, it's essential to maintain proper grounding and bonding. The equipment grounding conductor plays a critical role in providing a path for fault current to return to the source, tripping the overcurrent device and preventing electrical shock. It's important to bond all metal enclosures, such as the subpanel enclosure, to the grounding system. This ensures that any fault current will be safely conducted back to the source. In addition to the equipment grounding conductor, a grounding electrode conductor is also required. This conductor connects the grounding system to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode provides a connection to the earth, which helps to stabilize the voltage of the electrical system and provide a path for lightning surges to dissipate. When working with electrical systems, safety should always be the top priority. Firstly, always de-energize the circuit before working on it. Use a voltage tester to verify that the circuit is de-energized. Secondly, wear appropriate personal protective equipment, such as safety glasses and insulated gloves. Thirdly, follow all NEC requirements and local electrical codes. If you are not comfortable working with electricity, it's always best to hire a licensed electrician. To summarize, while number 4 aluminum is permitted as an equipment grounding conductor for a 200 amp service according to NEC 250.122, several factors need to be considered when using 4/0 aluminum quad Plex cable for a 200 amp feed. These factors include the cable's suitability for indoor use, the potential for corrosion, ampacity derating, and the need for proper grounding and bonding. It's often recommended to use a copper feeder with a larger grounding conductor, especially if the cable will be exposed or installed in conduit. Always consult with a licensed electrician to ensure safe and code-compliant installation. The NEC is not just a set of rules, but a comprehensive guide for ensuring electrical safety. By following its guidelines and understanding the principles behind them, it's possible to create electrical systems that are both safe and reliable. When working with aluminum conductors, it is also important to consider the type of connectors and terminals being used. As previously mentioned, aluminum is prone to oxidation, which can create a non-conductive layer on the surface of the conductor. This can lead to loose connections and overheating, which can be a fire hazard. To prevent this, it is essential to use connectors and terminals that are specifically designed for use with aluminum conductors. These connectors are typically made of aluminum or a bimetallic material, such as aluminum with a copper coating. They also often contain an antioxidant compound that helps to penetrate the oxide layer and establish a good electrical connection. There are several different types of connectors and terminals available for use with aluminum conductors, including compression connectors, mechanical connectors, and set screw connectors. Compression connectors are generally considered to be the most reliable type of connector as they create a very tight and secure connection. However, they require the use of a special compression tool, which can be expensive. Mechanical connectors are a more affordable option, but they are not as reliable as compression connectors. Set screw connectors are the least expensive type of connector, but they are also the least reliable. When selecting connectors and terminals for use with aluminum conductors, it is important to choose products that are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or Canadian Standards Association. This ensures that the products have been tested and meet the applicable safety standards. In addition to using the correct connectors and terminals, it is also important to properly install them. This means following the manufacturer's instructions carefully and using the correct tools. It is also important to torque the connectors to the specified torque value. Over-torquing can damage the connector, while under-torquing can result in a loose connection. Regularly inspecting and maintaining electrical connections is another essential step in ensuring a safe and reliable electrical system. This includes checking for loose connections, corrosion, and other signs of damage. If any problems are found, they should be corrected immediately. In addition to the technical aspects of working with aluminum conductors, it is also important to be aware of the potential hazards involved. Aluminum is a good conductor of electricity, so it is important to take precautions to avoid electrical shock. This includes wearing appropriate personal protective equipment, such as safety glasses and insulated gloves, and energizing the circuit before working on it. Aluminum can also be a fire hazard if it is not properly installed and maintained. Loose connections and overheating can cause the insulation on the conductors to melt, which can lead to a short circuit and a fire. To prevent this, it is important to use the correct connectors and terminals, properly install them, and regularly inspect and maintain the electrical connections. In summary, using aluminum conductors for electrical wiring can be a safe and cost-effective option, but it is important to be aware of the potential hazards involved. By following the recommendations outlined above, it is possible to minimize these hazards and create a safe and reliable electrical system. Remember to always consult with a licensed electrician if you have any questions or concerns about working with electricity. They have the knowledge and experience to ensure that the work is done safely and in accordance with all applicable codes and regulations. Furthermore, always remember to prioritize safety. Electrical work can be dangerous, and it is important to take all necessary precautions to avoid injury or property damage. With the proper knowledge, skills, and precautions, you can safely and effectively work with aluminum conductors and create a safe and reliable electrical system.